All right, hello, AB Calculus. Here we are with Related Rates Notes Part 2, the second two pages. So we've done questions 1, 2, 3, and 4 in the first video. Now we're on questions 5, 6, and 7, and 8. So let's get started so we can keep the video short. We have an airplane flying at an altitude of 6 miles. Altitude is height. And it's on a flight path that will take it directly over this station. So here goes our plane. Flying. If this plane is S miles from the tracking station and S is decreasing at a rate of 400 miles per hour, when S is 10, lots of information there. What is the speed of the plane? Okay, so we got to figure out where to label our diagram. So read through the problem several times and then label your diagram. Okay, excuse me. All right, so where are we going to put S? Are we talking about a distance, a lateral distance, or a distance from point A to point B? That's a little bit confusing to me in this problem. So let's look at what we're asked for, and that might help us make sense of where to put that S. So we're asking about the speed of the plane. Well, the plane is flying here. The speed's going to be calculated on the lateral. All right, so we're going to be looking for this, which is parallel to the ground. So we're going to label the base of our triangle as the speed. Okay, so this is where our speed is going to be calculated. Well, so that means our distance is going to be here. And this problem is using S for distance, which is kind of confusing because then they ask for speed, and those are both S letters. So we're going to label speed with V for velocity, and then we'll just analyze the speed from our velocity because they're, related by absolute value. So, this is our altitude. This is our velocity. And this is our distance to the tracking station. So the distance of this problem is intended to be from point A to point B. So this is 10 miles. All right. So S is decreasing at a rate of 400 miles per hour. So that's a rate. So we'll write ds dt right here. And decreasing is negative, so I'm going to put 400, and I'm not going to put units here because I'm out of time. I'll make sure I put, I'm out of space. I'll make sure I put them in my complete sentence. Okay, awesome. So important to note, this is a constant. The altitude is not changing. Okay, that is important. So if you were to do, how is the altitude changing, you would say 0 here. All right, so let's go over here. Our given rate is ds dt, and that is negative 400. We were asked to find dv dt, which is here. And we want to stop the problem at 10 when we have a 10-mile distance right here. That's where we're going to stop and analyze the problem. So we need an equation that will relate all this, hence the name of this is related rates. And our equation is going to be, of course, a squared plus v squared equals s squared. Okay, so I'm going to do these problems. They both involve a constant. I'm going to do each one a different way so you can kind of see what's happening with that constant. Do not sub anything into this problem until you've differentiated, unless it's a constant. If it is something that's not changing, it can go in right here. So this a can go in right here. You can go ahead and put that in. Let's go ahead and make it 36. And that's allowed because it's not going to, we don't need a rate to come in. The rate that comes in is going to be 0. Okay, so let's go ahead and differentiate. So that goes to 0, and then we get 2v dv dt equal to 2s ds dt. Okay, got a 2 on each side, so let's simplify our lives. All right, let's plug in v. I don't know it. Let's plug in dv dt. I don't know it. Let's plug in s. That's 10, and let's plug in ds dt, which is negative 400. All right, so I'm solving for dv dt, so that means I got to figure out what v is. So got to see if I can extrapolate that v somewhere in the problem, and it's pretty easy. This is 6. That's a leg of a triangle. That's 10. And so Pythagorean triple here, this is going to be 8. Okay, so if you need to do a quick Pythag analysis, please be my guest, but most of you probably know that triple. V is 8. All right, so we'll fill that in here. All right, and so dv dt is simply going to be negative 400 over 8, which, negative 4,000 over 8, which is negative 500 miles per hour. Okay, so the velocity of the plane is negative 500 miles per hour. So the speed, which is the absolute value of velocity, is 500 miles per hour, and we've answered the question. So what does this negative sign on velocity imply? Well, it just kind of means like as the plane is flying over the tracking station, the distance from the 2 points of interest, this is a point of interest and this is a point of interest, the distance between the two is getting smaller. So that well, it's coming this way. This distance is getting smaller, so that's a negative on the velocity. Once it passes the tracking station over here, the velocity would become positive. Remember, velocity is a kind of a directional thing, but in this case, it's sort of like a decrease in the distance between the two. And then as you go over here, that distance would be, getting bigger. So the negative side implies the distance to the tracking station is getting smaller or decreasing. It's getting a smaller distance. Closer. We're getting closer to the station, folks. Getting closer to the station. The velocity is negative. All right, I think that's it for that problem. The next one, we have our ladder, our falling ladder. This problem shows up a lot in, assessments with calculus. We have a 20-foot ladder. Hey, that's a constant. Okay? So note to self that that's a constant. What else? The bottom slides away at a rate of 20 feet per second. Okay, so this ladder is falling, sliding, something like that, okay? Just like that. So we're looking at this bottom sliding out and this top sliding down. So this is sliding out and this is sliding down. All right? So the bottom slides away, and we'll call this X, at a rate of 2 feet per second. The top of the ladder is at 12 feet above the ground. How fast is the top sliding along the wall? So how fast is the top heading towards the bottom? So notice that's a distance that's decreasing. This is a distance that'll be increasing. So watch how those rates play out. This is decreasing to this point of interest. This distance is increasing from here to here is increasing. So watch how that plays out. Okay, so let's see. Our given rate is dx dt, which is 2. We're asked to find dy dt when y is 12. We'll get our units in, with our complete sentence. Sometimes they can muddle things up in here. Okay, so once again, we have our Pythagorean theorem. So let's call this z. Okay, so x squared plus y squared equals z squared. So this time I'm going to forget to plug in my constant. Okay, so up here I got my constant in right away, and it differentiated to 0. Okay, and so that's great. So now I'm going to forget to do that just so you can see how that looks. So this is 2x dx dt. We are differentiating with respect to time. That's a non-match on the variable. Hence our need to implicitly differentiate. Okay, so 2's can cancel, that's good. X is, I don't know, but I do know, again, we have a Pythag situation, 12 squared plus x squared is 20 squared. Falling off the table here. X squared equals 400 minus 144. X squared is 256. Another triple x is 16. Okay? All right. So 16 here, and dx dt is 2, and y is 12. dy dt is what I'm looking for, so that's good. And z is 20, and then dz dt. We don't know dz dt, really, we don't, it doesn't look like we know dz dt, but in reality, we do. How is the size of the ladder changing? It is not. So it is a rate of 0 because the ladder is not decreasing in distance or increasing, it's staying constant. And so that would be 0. So you could go ahead and 0 it out after you differentiate there. So it's just another way to think about it. All right, so dy dt is going to be negative 32 over 12. Divide by 4, negative 8 over 3 feet per second. Okay, so the top of the ladder is decreasing. Okay, the top of the ladder is decreasing, or, you know, a better word here would be falling because of the decreasing, at a rate of 8 over 3 feet per second. Okay, and the negative sign implies that the distance, so it implies, I'm continuing in this sentence here, the distance from the top to the ground, you guys can't see, the top of the ladder is falling at a rate of over 3 feet per second. The negative sign implies the distance from the top to the ground is getting smaller. All right, so we had a positive rate here because this distance is getting bigger in this scenario, and this became a negative because math works, and that's getting smaller. All right, so we're going to use this information on the next two problems. We're almost done, but better to do the video here than trying to learn all of this before your final. All right, at what rate is the area of the triangle changing? All right, so what did we have? Let me take a peek here. 16, just label this really simply, 12 and 20. Let's see the diagram. This was dx dt was 2, dy dt was negative 8 over 3. All right, so find d area, dA dt. What is the rate of the area changing at that moment? So we know my area formula is, I was going to write base times height, but let's use x and y. All right, so this is going to require the product rule, okay? So note that these are two different functions with a variable. One is the base and one is the height. So we are going to differentiate that with the product rule implicitly. Okay, so dA dt is, I like to attach the what, you can factor out the 1/2. I like to kind of attach it to one of them. I'm going to attach it to the x. So let's differentiate x. That'll be, actually let's leave x alone. So 1/2 x alone and do dy dt, differentiate y. Okay, so I've left 1/2 x alone and I just did dy dt. Plus, let's leave y alone and let's differentiate x. So that'll just be 1/2. And then dx dt. So you can see here how you could have that 1/2 just out in front and do the product rule in parentheses if you like, because it's going to apply to both of them here as we leave it alone, and then when it differentiates it's just this constant multiple. All right, so let's plug in. dA dt is 1/2 x, so x is 16. dy dt is negative 8 over 3 plus 1/2 y is 12, and that's 2. Okay, so let's just do our numbers here. This will be cancel 8, negative 64 over 3 plus 12. So what, negative 64 over 3 plus 36 over 3, I get negative 28 over 3. So the area is decreasing as the ladder falls. As the ladder falls, the area is decreasing. It's going to decrease to, once the ladder's down, there'll be 0 area at a rate of negative 28 over 3. Oh, no, we got decreasing in there already, so get rid of the negative since this takes the negative into account. My units were, I can't remember, feet per second, so area is feet squared per second. Okay, so the negative sign implies the area is getting smaller. All right, the area is getting smaller as the ladder falls from 12 feet to the ground. All right, last one. How fast is theta, the angle between the ground and the ladder changing at that moment? Okay, so we want to find d theta. We know so many rates here, so we're in good shape. So we just need to relate these rates and pick, a formula that'll work for us. So wait, x16, y12, z20, dx dt, 2 dy dt equals to negative 8 over 3. Okay, and so an equation, what I could write, to find, I got to find d theta dt. I could use, sine, cosine, tangent, whichever one you want. Eeny, meeny, miny, mo. Let's use sine. So the sine of theta is equal to, we're going to take the sine of theta here. It's going to be opposite over hypotenuse. And so that is a constant of 20. Okay, so we'll get d theta dt into the picture once we differentiate sine. All right, so let's see, this was actually pretty easy. So the derivative of sine is cosine, and theta does not match with our taking the derivative with respect to time, so in comes d theta dt, which is good news because that's what we're solving for. Okay, this is just we don't need to do anything crazy like quotient rule or anything. Remember, this is just a scalar, so 120, right? Differentiate y to 1, and then in comes dy dt. So this time, this 20 did not zero out because it's part of this monomial. It's not a monomial or a term in of itself. All right, so what is the cosine of theta? Well, the cosine of theta is going to be negative, or it's going to be positive 16 over 20. Okay, d theta dt. And this is 1 over 20 times negative 8 over 3. All right, so let's see what we got here. D theta dt is 1 over 20 times negative 8 over 3. Let's do 20 over 16. Okay. So this is negative 1 over 6. So that angle is getting smaller or decreasing at a rate of 1 over 6. And how do we measure in calculus angles? Radians per second. All right. I think that's it. Okay, so you should be all set to do 37 and 38 homeworks. You might need to maybe try to practice these, but these two also, I don't know. But this is what we'll start the class with when we return, going through this lamppost and this hot air balloon problem. Okay, have a good one. Thanks for watching, and we'll see you guys next time. Bye.